All the Little Things was a harder web challenge from the Google CTF 2020. In the end, only 20 teams solved it. This challenge is almost like a part 2 from the easy pasteurized challenge, so make sure you have seen that too. As it is with most harder challenges, this also was a team effort. Multiple people of our team Alice contributed to the solution. So, let me tell you how we solved it. I left a little secret in a note, but it's private. Private is safe. And note, TJ Mike from Pasteurize is also logged into the page. This already tells us that, like Pasteurize, this is a browser client-side hacking challenge. So XSS, CSRF, that kind of stuff. So let's start by checking out the functionality. We can log in by using a username and a profile image URL. The image is then embedded up there, and we can access settings, notes, and log out. In settings, we can change the name, profile picture, and theme. There's a dark mode and a light mode. Then there is node, where we can create a new node and we can make it private or public. If we make a public node, just as a test, submit anything, it shows up in our list of nodes, but it actually redirects to the Pasteurize challenge. So public nodes are submitted on Pasteurize. Let's go back to the Little Things domain and make a private node instead. Like with Pasteurize, we could try some XSS payload, an HTML tag and an image tag with on arrow. Submit it, and then it shows up in our list of nodes. And private nodes are now displayed on the Little Things domain. As with Pasteurize, some HTML got rendered, but only what is safe. The on arrow handler of the image was removed. When we look into the static page sources, we can see that it basically looks the same like Pasteurize. Here's the node content, including the XSS payload, and then it is passed into DOM Purify Sanitize, which we know is safe. We could also try the trick from Pasteurize for the XSS, but it doesn't work. In fact, after the CTF, the author of the challenge shared that the vulnerability in Pasteurize was actually first in this challenge or the Little Things. But it was an easy unintended bypass, so he fixed it and created Pasteurize as an easy introductory challenge with this bug. Anyway, after that, I just started looking through all the given sources, mainly the utils.js, users.js, and theme.js. Those are the custom JavaScript code that make this website work. And if we try to find some kind of XSS, it's probably somewhere in there. And the code turns out to be really fishy, so there was already a feeling for, yeah, this looks so weird, there must be an issue here. For example, in theme.js, the update theme function takes the configured theme from the document username object, then creates a script tag where it embeds this theme URL with a CB parameter. If we look at the request sent when you load the page, you can see that the theme could be, for example, setLightTheme, and then the response of this URL looks like this. So this is a JSONP API endpoint. I briefly introduced JSONP and how it can lead to issues in the Google Sheets XSS video, so watch that if you want some additional information. Here the script simply uses the callback parameter as a function name to call this function. So when embedding this as a script, it will call setLightTheme, which is defined in theme.js as well, and this function simply updates the CSS of this page. The callback parameter can also be kind of freely chosen. So for example, we could enter here alert, and now we have a script hosted on the Little Things website that calls alert. And this will become important soon, let's remember that. Other than that, we have a user.js file which contains a user class. A user has a name, an image, and a theme. In the function makeUser object, this user is created. The image source of the profile image is set, and also update theme is called. There's also this weird load debug function call, but we don't know what this is for now. Just FYI, the question mark is a special syntax that basically means if load debug is undefined, do nothing. If it exists, call it as a function. So this is just a shorthand to make sure there is no error if the function doesn't exist. And then we come to utils.js, and this looks like the start of everything. It triggers when the DOM of the website is loaded, and it triggers a fetch request to /me, which turns out to respond with the user data in a JSON format. It then takes the JSON and calls makeUserObject on it, so that triggers the chain of creating the user and then updating the theme with the JSONP callback. At this point, we were still missing one important detail that we missed. We thought we explored everything, but we didn't. Regardless, we started to think about possible exploits. We knew the goal is to access private nodes of TJ Mike. He must have a private node with the flag in it. We didn't have full XSS anywhere yet, but we knew it must be browser client side related. So we started to experiment. The nodes did allow some HTML. Not JavaScript, no XSS, but it allowed HTML tags. And there's a technique called DOM clobbering using HTML ID and name attributes. Here's an example. Let's create a node with a div using an ID like blah. This is definitely allowed as it is not XSS. But this does something to the DOM. If we go into the JavaScript console, we can access this HTML tag via window.blah. Window.blah points to our div. Notice something? Remember the window.load debug that is checked if it's undefined or not? We could create an HTML tag with the ID load debug and then it exists. Let's try it. Submit this and here it is. If we look now into the JavaScript console, we can find an error. Window.loadDebug is not a function, which makes sense because it is an HTML div element object. So I thought maybe there's a trick. Maybe there is a weird HTML element that is also a valid function. This is a very wild idea. I would have never thought to check something like this if it weren't for this challenge. But finding such an HTML element could be a very cool DOM clobbering trick. So let's do some security research. Let's try to find such an element. First, I looked up a big list of possible HTML elements on GitHub. I just took a random list, don't even know if it's complete. Then I put it into a JavaScript array and looped over each element. On our nodes, we know that the script tags are removed by DOM purify. So for each tag, I call DOM purify sanitize on it just to make sure it is allowed and gets through. The element I create also gets the ID x so that we can then try to call window.x as a function. This is all inside a try catch because most likely this won't work and throws an error. Window.x is not a function. But if it survives the function call, we print found. Now I simply execute this code in the developer console. It super quickly runs through and finds nothing. Crap. Oh well. This is a typical dumb idea you might have. You test it and you find out it doesn't work. But that's security research. I think it was a good idea and worth testing for. And now we know this probably is not the path to the solution. After that, we continued looking for other things we could clobber. I mean, there's window.username, but it's assigned here, so it would override our clobbered value. Or here is a query selector for the ID bootstrap link, which we could also try to include in our node. But this code is actually executed before it renders the node, so it doesn't work. And even if it would set the href, I don't really know if this would help us. So we were kind of stuck. I started to get a bit frustrated when I clicked through all the sources again. And then I noticed this debug get parameter. This is a small important detail I missed earlier. Adding this to the URL, it will add a new debug.js script, and it also adds some additional HTML into the settings page. This debug.js script actually defines the load debug function. It takes the window.name, interprets the string as JSON, and this line, the object assigned, merges this debug JSON object with the user object. It then has some additional features. You can turn verbose mode on, show all hidden HTML elements, and keep debug, which adds the debug get parameter to all the anchor href links that it finds. On error is also overwritten with alert. This obviously gets us forward. So with debug turned on, we get this debug input form in the settings. And all this does is you can write there some JSON and it will set the window name to this JSON as a string. So let's write some JSON that sets verbose, show all, and keep debug onto the user object. Refresh the page, and now you see it changed a bit because things like show all revealed all the hidden elements and made them blocks. Window.name is now set to this JSON string. Upon every page load, if the debug parameter is set, the debug.js script with the load debug function reads and parses the string as JSON and then applies it to the user. And then these attributes become available on the user object. And for those that don't know, window.name is special because see what happens if I go to a different website in the same tab, LiveOverflow.com, and now check the window.name. It is still the same. Window.name persists across other websites. This gives us an entry path. The video is getting quite long and there was so much info input already. I think this is a good moment to stop. If you haven't solved this challenge yourself, now is a good point to try it again. You can find the link to the challenge in the description. But there are still a few more little tricks involved. but let's talk about it next video.